Hi viewers, I'm Emmanuel Johnny. In today's video, I want to provide solutions to Math 121 manual. This is actually Unit 2. So I'm just going to provide the solutions to the questions. And there are basically 3 questions there. So let's begin with the first one that says, find the derivative of the function f of x equals to root x if x is greater than 0 at each point in its domain. All that is English. All you need to do is just to differentiate this function. So the solution, so if f of x is equals to root x, we want to differentiate this function. F of x, you can also say y is equals to, so this is f of x which is equals to root x. We can rewrite this as, remember that when you want to differentiate a function, for instance, say y is equals to x cubed, it's very easy. What do? You write that dy over dx is equals to the power times the coefficient. So 3 times 1 is 3. Then x raised to power. Then the power minus 1. That is 3 times 1, 3. Then 3 minus 1, you have 2. That is how to differentiate a function. So applying that same method, that's how you differentiate this function. Now remember that the function you are differentiating must be in power form, just like this one now is in power form. So the first thing I will do is to rewrite this function in power form as f of x equals to x raised to power square root sign in mathematics is 1 over 2. So this means x raised to power 1 over 2. To differentiate this, you now say f prime of x, which is the same thing as dy dx. So since it is given in terms of f of x, that's why I'm using f prime of x, which is the same thing as dy dx. So f prime of x is equals to, remember the simple way to differentiate, it is power times coefficient. So the coefficient is 1. Half times 1 is half. Then x raised to power half, don't forget, minus 1. Power times coefficient, then subtract 1 from the power. Alright, so half times 1 is half, then half minus 1. Look at it here. So which means that f prime of x is equals to half x raised to power. This is half minus 1. If I say 4 minus 2, the answer is 2. And if I say 2 minus 4, the answer is minus 2. In other words, big number minus small is positive, but small minus big number is negative. Likewise, 1 minus half is half. One thing, remove half, you have half. Likewise, if I say half minus 1, that is now small minus big. That will give you minus half. So, half minus 1 is minus half. This means that f prime of x is equals to 1 over 2 times, from the laws of indices, if I have a raised to the power minus n, we say that this is written as 1 over a raised to the power of n. How? This small minus here is 1 over. So when I take the small minus to mean 1 over, what am I left with? I'm left with a raised to the power of n. So you bring it down, a raised to the power of n. In other words, if I have 2 raised to the power minus 3, I will write this as, this small minus is 1 over, then 2 raised to the power 3, bring it down, 2 raised to the power 3. That's the same thing I have here. Since I have negative power, this small minus here is 1 over. Then I'm left with x raised to the power 1 over 2. You bring it below, x raised to the power of 1 over 2. Okay, from here now, this is numerator times numerator, denominator times denominator. So that means that f prime of x is equals to 1 times 1 is 1 all over 2 times x raised to the power half is 2x raised to the power of half. So which means that f prime of x is equals to 1 over 2. Now don't forget that we said root x is the same thing as x raised to the power 1 over 2. So after differentiating, since I have x raised to the power 1 over 2, remember that 1 over 2 means square root. So you put it back. This means square root of x. So that is the derivative of that function. So in a nutshell, if f of x is equals to root x, then dy dx, which is f prime of x, is equals to 1 over 2 root x. That is how to differentiate that function. Okay, so this is just the number 1. Now we'll look at the number 2 in that manual. All right, so this is question number 2, still in unit 2. It says, find the dy dx at minus 1 over 2, comma 1 over 2. So these are the coordinates of the point where this is x and this is y. Now, this type of function here is called an implicit function. Now, how do you differentiate implicit function? There is a way to go about it in the long cut, and there's also the way to go about it using the shortcut. But definitely, I'm going to use a shortcut to differentiate this function, and it's interesting. So let's watch. So the solution. So I have half x sine pi y plus y minus x squared equals to 0. Remember, I'm just providing solution to this question. So I may not really dwell so deeply in teaching, but definitely I will solve the problem. So how do you solve this problem implicitly? Now there's a shortcut to solve this that requires using a certain formula. And the formula is that dy over dx equals to negative of partial x over partial y. That is, you differentiate the function partially with respect to x and then partially with respect to y. How do you do that? Let's go. So, I want to differentiate this function with respect to x. So that means that dy over dx is equals to minus into. So let's differentiate with respect to x. When we say differentiating with respect to x, what does it simply mean? When you look at the function, only differentiate the variable x. Let me stop there so I don't get to confuse you. So I want to differentiate with respect to x. Look at this particular function. Is there x inside? Yes, look at it. What's the derivative of x? You've learned this before now, that the derivative of x is 1. So now let's differentiate x. The derivative of x is what? 1. Then 1 times the whole of this. Let's multiply. So the derivative of x is 1. 1 times half is half. Half times sine pi y is sine pi y. Okay? So you have half sine pi y. We are done with that. Now don't forget, we are differentiating with respect to x. Question, is there x in this other term here? No. Since there is no x, then automatically it is considered to be 0. We move to the next one. Is there x there? Yes. So what's the derivative of x squared? The answer is 2x. So that means we have minus 2x. So we are done with differentiating this function with respect to x. Now let's differentiate with respect to y. So this is all over. With respect to y, is there y in this particular term here? Yes, there is y. But look at the y here. Is there y here? Yes, there is y. So that means we'll differentiate. But is there y here? No. That means automatically this is 0. Let's go back to differentiating this. So if I want to differentiate this now with respect to y, this is not just an ordinary y, but it is sine pi y. That means that you must have known how to differentiate trigonometric function. Okay, let me give you an instance so you can understand better. If I have sine 2x, I want to differentiate this. To differentiate a trigonometric function, you use chain rule to differentiate, but you can also use a very short cut. So let's say that y is equals to sine 2x. Then dy over dx will be equals to. How do you differentiate it in a very simple way? Go to the polynomial function, which is 2x. What is the derivative of 2x? The answer is 2. Okay, you write it down here. 2. What is the derivative of sine? It is cos. Then repeat the polynomial function 2x. 2x. You are done differentiating. So what did I do? Step 1, differentiate 2x. You have 2. Step 2, differentiate the sign. You have cos. Step 3, repeat the polynomial here, 2x. Look at it, 2x. That's the same method you are going to use to differentiate sine pi y. So at this point, this is like sine, this is like 2 now, which is a constant. That pi is like a number 2. And then y is like the variable now, x. So the same way you differentiate this, the same way you are going to differentiate this. Now let's differentiate this. So remember, I'm differentiating with respect to y. So I'll go straight to y. What's the derivative of y? 1. So look at it. If you differentiate y, you have 1. 1 times pi, just like you differentiate x, 2x here, you have 2. Remember, the derivative of x is 1. 1 times 2 is 2. So the derivative of y is 1. 1 times pi is pi.